Good afternoon, students. Today topic is stereoselectivity and strategies of asymmetric synthesis. Stereoselectivity and strategies of asymmetric synthesis. Very important. That is stereoselectivity. So complete unit is depends upon stereoselectivity. So there is a enantiomer selectivity and diastereo selectivity, and the product selectivity and substrate selectivity. Some is there. And explain with brief examples. Okay. So first we are seeing that one chart is there, and that is selectivity. Okay. So selectivity, two types: substrate stereoselectivity and product to stereoselectivity. And substrate stereoselectivity, two types: substrate enantiomer selectivity and substrate diastereo selectivity. Product to stereoselectivity, two types: and product enantiomer selectivity and product diastereo selectivity. And product enantiomer selectivity, again product enantiotropic differentiation and enantiophase differentiation, diastereotopes differentiation and diastereophase differentiation. So like this differentiations are there. We are discussing these 6 things covered in stereoselectivity. One by one we are discussing. First is stereoselectivity. Again we are discussing stereoselectivity. Stereoselectivity. Stereoselectivity in a chemical reaction, if unequal amount of stereoisomers of chemical stereoisomers are the product, then that is called stereoselectivity. We are discussing already. Again, first substrate stereoselectivity. First one is substrate stereoselectivity. Substrate stereoselectivity. Substrate stereoselectivity. So in the substrate stereoselectivity, in a chemical reaction, if the attacking agent, substrate stereoselectivity, in a chemical reaction, if the attacking agent, that is a reagent, catalyst, solvent, is able to discriminate the stereoisomers, suitable such substrate that gives the reaction must be starts with a mixture of stereoisomers. Attacking agent exclusively react with only one stereoisomers. Okay, so in substrate stereoselectivity, the reaction start with the mixture of starting materials. That means we are taking 2 starting materials in substrate stereoselectivity. The attacking agent is maybe achiral, maybe chiral. In substrate stereoselectivity, the reaction starts with a mixture of reactants. The attacking agent may be achiral, chiral, then gives products. Okay, so these 2 A and B, the starting materials must be with stereoisomeric substrates. The starting materials must be with stereoisomeric substrate. The starting materials must be with stereoisomeric substrates. Okay, na? That's again this substrate stereoselectivity classified into 2 types. One is enantiomer substrate, enantiomer selectivity, substrate diastereo selectivity. First we discuss substrate enantiomer selectivity. First we discuss substrate enantiomer selectivity. That means here mixture of enantiomers. We are taken a mixture of enantiomers are the reactants and mixture of enantiomers are the reactants. That enantiomers is a enantiomeric substrate. These two are the enantiomeric substrates. Enantiomeric substrates. Attacking agent. Attacking agent must be with chiral. Must be with the chiral. The attacking agent preferentially react with one function group, one enantiomer. The attacking agent preferentially react with one enantiomer, Okay. Best example, plus or minus ammonium tartarate. Best example is plus or minus ammonium tartrate. These ammonium tartrates are enantiomers, and attacking agent is penicillin glucum. Penicillin glucum. This enzyme, all enzymes are considered as a chiral. This enzymes preferentially react with one starting material, one enantiomeric substrate. That means they gives the attacking with minus ammonium tartarate. Minus ammonium tartarate plus ammonium tartarate is consumed by enzyme. Plus ammonium tartarate is consumed by enzyme. Next example is DL-glucose. When reacting with yeast, then gives L-glucose. D-glucose is consumed by yeast enzyme. So this is a substrate enantiotopic selectivity. Substrate enantiomer selectivity. In substrate enantiomer selectivity, here we are taking mixture of two enantiomeric substrates. The attacking agent is chiral. The attacking agent preferential react with one substrate and gives one major product. Okay. Here I am taking plus or minus ammonium tartarate. When reacting with penicillin glucum, then reacting with plus ammonium tartarate, they consumed by this enzyme and relieving this ammonium minus ammonium tartarate. When another example, DL-glucose, when reacting with yeast consumed by D-glucose, then leaving L-glucose is a single product. Next one is substrate diastereo selectivity. Substrate diastereo selectivity. Substrate diastereo selectivity. Okay. In a chemical reaction, the attacking agent discriminate to diastereomers is known as substrate diastereo selectivity. The substrate must be diastereomers. That attacking agent may be chiral or chiral. Producers may be chiral or chiral the product. When that reaction start with a mixture of diastereomeric substrate, the reaction starts with a mixture of diastereomeric substrate. The attacking agent may be chiral or achiral. This attacking agent preferentially react with one diastereomer and they gives products. Okay. Example is cis 4-tertiary butyl cyclohexanol. This is, and another one is trans. When these two reacting with chromic acid, this reaction is fast. This reaction is very slow. Okay, that attacking agent is the chiral or maybe chiral, then reacting with one diastereomer and by leaving other diastereomer. This is another example. One example for substrate diastereo selectivity. Next one is product stereoselectivity. This is important. Next one is product stereoselectivity. Product stereoselectivity. In this product stereoselectivity, here substrate must be with the stereotropic units. Substrate must be with stereotropic units. Stereotropic units, that is enantiotropic units or diastereotropic units. That is enantiotropic units, topic units or diastereotropic units. The attacking agent, when attacking agent is maybe chiral, maybe achiral, then gives unequal amount of stereoisomers. Unequal amount of stereoisomers and gives unequal amount of stereoisomers. That is called enantiomers or maybe diastereomers. So enantiomers are all enantiomers are chiral. Diastereomers may be chiral or achiral. Okay, like this. Okay, so that means substrate stereoselectivity. The substrate must be the stereotropic units, that is enantiotropic units or diastereotropic. The attacking agent may be chiral or achiral, then gives unequal amount of stereoisomers, that is enantiomers and diastereomers. Okay, first we are discussing product enantioselectivity. Product enantioselectivity. Product enantioselectivity. So in this product enantioselectivity, substrate with the enantiotropic units, substrate with enantiotropic units, the attacking agent must be with chiral, then gives unequal amount of enantiomers. Then gives unequal amount of enantiomers. Amount of enantiomers. So this is the product enantioselectivity. That means in this product enantioselectivity, that reaction start with only one substrate. The substrate must be with enantiotropic units. The attacking agent is chiral, then gives unequal amount of enantiomers of the product. Again, this product enantioselectivity classified in two types. One is product enantiotope differentiation reaction and product enantiophase differentiation reaction. First, we are discussing product enantiotope differentiation reaction. Product enantiotope differentiation reaction. Just discussing it. Product enantiotope differentiation reaction. Example is these are the enantiotope ligands. These are enantiotope ligands. When reacting with ATP then gives, this is nomenclature is pro-R, this is pro-S. So ATP attack it only pro-R only. This is the major product will be used. So enzyme attacks only pro or ligand only. Next one is B. Product diastereotope differentiation reaction. Product diastereotope differentiation reaction. Product diastereotope differentiation reaction. Okay. So example I am taken. Ethyl acetate when reacting with Baker's yeast. So Baker's yeast attack only on rephase only. R is the major. This gives about 99.99% is the major product will be formation takes place. This is the product diastereotope differentiation reaction. Next one is product diastereo selectivity. Diastereo product diastereo selectivity. So here the substrate in this product diastereo selectivity, the substrate so must be with the diastereotopic units, must be with the diastereotope units when attacking agent is maybe diastereo means achiral or chiral, then gives unequal amount of diastereomers, then gives the products are unequal amount of diastereomers are the products. Again, this is classified to suit up product to diastereotope differentiation reaction, product and product enantiomer differentiation reaction. First one again here, product diastereotope differentiation reaction. So here example is bromine H, here phenyl when reacting with the base, loss of HBr, E2 elimination, they gives trans and cis. This is a major and this is minor. Okay, this is a product diastereo differentiation reaction. Next one is product diastereophase differentiation reaction. Product diastereo differentiation reaction. So here, so when reacting lithium aluminum hydride, then gives trans is major. This will gives minor. So this is the product diastereophase differentiation reaction. Next one is Next one is very, very important. Enantiomeric excess. Percentage of enantiomeric excess. Percentage of enantiomeric excess. Percentage of enantiomeric excess. Excess of one enantiomer over the rest mixture is called enantiomeric excess. So what is excess of one enantiomer over the racemic mixture is called enantiomeric excess. Racemic mixture. Racemic mixture means 50-50% is called racemic mixture. 50-50% is called racemic mixture. So over is a enantiomeric excess. First, I am telling you here one example. One example is there. When substrate undergo reaction gives alpha plus beta. So alpha is 90% and beta is 10% is given. So alpha is 90%, beta is 10%. Okay. So what is the enantiomers? Racemic mixture means 50-50. Okay. So you have 10 plus 10, 20. So actually, so here 10 means 80 is the enantiomeric excess. 80 is the enantiomeric excess. So how to identify this percentage of enantiomeric excess means percentage of yield of major enantiomer minus percentage of yield, very, very important, percentage of yield of minor enantiomer. Percentage of yield of major enantiomer minus percentage of yield of minor enantiomer. So here, so how much percentage of major enantiomer? 80% and minor is 10%. So how much excess enantiomeric excess? 80 is the enantiomeric excess. So we can calculate percentage of racemic mixture. Here from here, percentage of racemic mixture is 100 minus percentage of enantiomeric excess. So here in this case, so how much percentage of enantiomeric excess? 80. So that is the racemic mixture is 20 is the racemic mixture, because 10 plus 10 is 20 is the racemic mixture. Okay. Percentage of yield of, next one is percentage of yield of major enantiomer. Percentage of yield of major enantiomer is equal percentage of one enantiomer in racemic mixture plus percentage of enantiomeric excess. So this is a percentage of yield of major enantiomer. Okay. So what is the percentage of one enantiomer in racemic mixture? 20 means racemic mixture means 50-50 now. So 10 plus 10, how much? 10. So next one is how much enantiomeric excess? 80. That gives 90. So this is 90 is the percentage of major enantiomer. So like this, these three principles are useful in the calculation of percentage of enantiomeric excess. So percentage of enantiomeric excess is called percentage of yield of major enantiomer minus percentage of yield of minor enantiomer. Next one is percentage of racemic mixture is equal 100 minus percentage of enantiomeric excess. Percentage of yield of major enantiomer is equal 100 percentage of one enantiomer in racemic mixture plus percentage of enantiomeric excess. This is the three principles in the calculation of percentage of enantiomeric excess. Next one is determination of enantiomer composition. Determination of enantiomeric composition. So very, very important. One is determination of enantiomer composition. Determination of enantiomer composition. determination of enantiomer composition. So by NMR spectroscopy methods. So based on NMR spectra method. So based on NMR spectra method. Based on NMR spectra method. So in this, generally enantiomers. The enantiomers, the definition is non-superimposable mirror images are enantiomers. Enantiomer separation of enantiomers. Separation of enantiomers depends upon medium. In chiral medium, enantiomers are not possible to differentiate. In achiral medium only, in achiral medium, enantiomers are not separated. In chiral medium, enantiomers can only separated. In chiral medium, enantiomers are converted into diastereomers. Then these diastereomers are separated by medium easy possible. Then these diastereomers are easily converted into again enantiomers. First, we have taken one enantiomeric picture. This is an enantiomeric picture. So enantiomers are not possible to separate physical methods. So we can convert it into diastereomers. Then only we can separate the enantiomers. Enantiomers are separated by physical methods, that boiling point, melting point methods, etc. So when these enantiomers are reacting with the chiral substrate, these enantiomers are reacting with chiral substrate. This is a chiral. When these enantiomers are reacting with chiral substrate, then forms one diastereomeric mixture. It forms a diastereomeric mixture. These diastereomers are easily separated by physical methods, that is melting point, boiling point, and these density and etc. methods. So when these diastereomers after hydrolysis, we are getting our enantiomer. Like this, enantiomers are separated by reacting with the chiral reagent, then converted to diastereomers. These diastereomers are again hydrolyzed, then gives our enantiomers. Like this, we can separate the enantiomers. Okay, this determination of enantiomer composition by NMR spectroscopic method. And some metallic compounds are there. That is the example is that metals are europium, praseodymium, ytterbium, etc. Like this, we can separate the enantiomers. So next class we are going to discuss strategies of asymmetric synthesis and substrate control method, auxiliary control method, reagent control method, and catalyst control method. So next class we are discussing. Thank you.
Murli sir.
Tell me.
Sir, I'm GSM Murthy.
Tell me. Murthy.
Sir, can I have your phone number, sir? I've given my number to you.
Oh, yes. I will call you on Monday.
Okay,
Tomorrow. Okay. Murthy,
right, sir. Right, sir. Thank you, sir.
I have your number on my notes. 9491. Like that is your number, na?
Yeah, 949, sir. Correct.
That I will call you on Monday. Okay.
Thank you, sir. Thank you.
And I send that notes also to you, Murthy and Garu. That is.
Thank you, sir.
Synthetic strategies notes, so you can send to your friends. Okay.
Sir, right, sir.
Okay. Thank you.
Thank you, sir. Thank you, sir. Thank you for today.